Hi, everyone. Today, I am going to discuss another thing that we see when we do experiments, just a couple terms, a couple things that we use to make our experiments more robust. So you've watched a video on scientific method today or yesterday about by Khan Academy, and it had a few things in there like how to design an experiment. Well, one big part of experiments is having a control group and variables that we manipulate. So the whole idea when you make a scientific experiment is you want to change just one variable. And the reason we do one at a time is, let's say you're testing a couple things that would make, like, for example, a plant grow, like we talked about the other day. We discussed that if you change two or three things at once and the plant grows more, you really can't tell which one of those factors caused that plant to grow. So what we do is we try to hold everything constant and change just one thing at a time. And that will tell us, at least give us a better idea if that variable is causing something to change. And we have names for these variables, and we're going to talk about that. So right now, I'm just going to throw those three terms out there. And afterwards, I have a short worksheet for you to do just so you can kind of read some experiments and see if you can identify what these are. So I'm going to go ahead and share the screen here. Let me get this going. And okay, so the assignment is called Identify the Controls and Variables. So let's take a look. What is a control? Well, we call it a control or a control group. And the word control means something that's kind of, I guess, in your hands, you're capable of manipulating it. And that's what a control really is. It's something that you can compare things against. I mean, you have to have a control group in almost all experiments. It almost always makes sense to have one. So let's take a look at what they are. So let's say you have an example of a bunch of different cars. So you have three cars and you paint these cars bright red. And you want to see the effects of various things on the car's paint. So let's say a car manufacturer wants to know how long their paint will last. So here's a car here. We're going to make a couple cars, and what you want to do is these cars are all going to be white cars, and we want to see what happens to them when they're out in the elements. So just in a simple experiment, and this is just a simple experiment to see what happens when these cars are left outside. So let's say we left one car out in the shade. So this one's in the shade. This car right here is just out in the sun. And there's just some various conditions I'm making up as we go along. Now, this car over here, this is in a garage. Oops, spelled that wrong. Garage. And it's covered. So what you do with this car is you put it in a garage and you cover it with a car cover, like a sheet or something that goes over it, so it's not exposed to anything. This right here is our control group. So after the experiment, you leave a car outdoor in a shade for a while. You're going to compare the car that's in the shade to the car that was in the garage and covered, because the car that's in the garage and covered should have no changes to the paint, really. It's just in a controlled, nice dark condition. It's covered, nothing can touch the car, anything like that. So it's the one that we're keeping pristine. And then the other one, you'll also compare the car that was out in the sun to the car that was in the garage covered. So what the control does is it gives us something to compare things to. You could do the same thing with clothing. Let's say you wanted to see the effects of weather on clothing, like these modern day shirts. I could get three shirts. This one, I would just pack away in a closet, something like that, so it can't get affected by anything. And it's going to look brand new. And you compare the effects of the other ones against something that hasn't been changed at all. So that's our control group. And it's just something we use. When we use these all the time, when you make things like drug studies, like your control group would be the group that doesn't get the drug. It's like your placebo group. So um, then you give some people the drug, some people you don't give a drug that you're testing for, and you don't tell which group anything about it. You don't tell them, they're blind. Say, okay, nobody's going to know if you get the drug or not. And then you have compare the group that had the drug against the group that didn't have the drug, which is your control group. So that's kind of how they work. So the control is something that you're comparing against. Now we're changed. Notice when we did the cards, we changed some things here. We put one in the shade and one in the sun. These are called variables. Now with the variables, it's something that you can manipulate. And we have two types of variables. We have the independent variable, and then we have the dependent variable. And it's very easy to get them to confuse the way get them confused. And the way I always remember this is the dependent variable is the one that depends on something else. So it's dependent on the change you make. The independent variable is actually the change that you make. So that's what it is. So let's take this example with the cars again. So we have a car that's in the garage and covered. This is our control group. And then we have these variables, shade and sun. Now, during an ideal experiment, we would only change one of these at a time. We would have a simple hypothesis that said, okay, a car that is out in the sun will deteriorate more than a car that is left in a garage and covered. So let's design that experiment. I have a garaged car here. This one, another white car. It's in the garage and it's covered. So it should stay pristine, same condition as it rolled off the lot. Then over here, we're going to have another white car. And this car is going to sit out in the sun, sit out in your driveway, whatever, just it's out there in the elements. And we're going to measure how much the paint weathers. That's what we're checking for. Paint weathering. So what are the two variables in this experiment? Well, the independent variable is the one, generally the one that you change. And it's like this in almost every experiment. So the independent variable is the one you change. So what are we changing here? Well, we're changing the amount of sunlight or the amount of atmosphere, the amount of outside that the car is exposed to. So our independent variable would be how much sun, how much climate is it being exposed to. Now, the dependent variable is the one that depends on that independent variable. It's the one that depends on what happens to other variables. So what are we looking for here? What would the sun cause? Well, it causes weathering. So the amount of paint weathering is our dependent variable. And a good way to think of that is the amount of weathered paint, how much the paint breaks down, is dependent on how much sun it sees, because the car in the sun is probably going to break down a lot more than the car in the garage. The covered car is not going to be exposed to ultraviolet rays or anything like that that breaks things down. So again, the dependent variable is paint weathering. It depends on how much sun hits it. The sun would be the independent variable. And that's probably the easiest way to remember it. The dependent variable depends on something else you changed. Here's another example. Let's say we had 3 plants. One plant we just left indoors, okay? And we just watered it. And another plant, let's say 2 other plants, we put these outdoor and we watered them. So we have 2 plants outdoors. We could have more. We could probably get away with 1, but 1 was indoor. And we want to see how much this plant grows when it gets a lot of sunlight. So we're watering all 3 plants. The only difference is 1 is indoor, so it's just getting, a nominal amount of light. And the other 2 outdoor ones are getting a lot of sunlight. So we could make 2, 3, 4, 5. The more samples you have, the better. We could have 100 plants. That would be perfect. So let's take a look at what these groups and variables are. Well, think about which one the control would be. It's fairly, I guess, obvious, or it seems kind of, easy to figure out that the control group would be the one that is indoor. What we're measuring is how much sun causes the plant to grow. So the one that is indoor would be the control. We're going to compare the ones that were outside to the one that was inside. So our inside group is going to be our control group. It's the one that we're comparing against. Now, what is our independent variable? Well, what are we changing? Well, we're changing the amount of sunlight and we're putting them outdoors. So the amount of sun would be our independent variable. What is our dependent variable? Well, what depends on how much sun it gets? And that would be what we're measuring, and that's growth. So that's just kind of in a nutshell how these experiments are designed. So in today's worksheet, I'm going to bring that up for you. What you're gonna do is you're gonna look at some short paragraphs or short problems, and you're gonna try to figure out what is what. So let's take a look here. So on the worksheet right here, it says, the first one, it says Smithers thinks that a special group, or I'm sorry, a special juice will increase the productivity of workers. He creates two groups of 50 workers each and assigns each group the same task. So the same job. In this case, they're supposed to staple a set of papers. So he has two groups of 50 workers and each group has to staple a set of papers. Group A is given the special juice to drink while they work. Group B isn't given the juice at all. They're just, juice free. After an hour, Smithers counts how many stacks of paper each group has made. So how many have they stapled? Group A made 1,587 stacks. Group B made 2,113 stacks. Group B ended up making a few more. So what I want you to do here is identify the control group, identify the independent variable, the one that we're manipulating, and then what depends on that? What was the response? What happens as a result of that independent variable that we manipulated? Like changing sunlight affected growth. Growth was dependent on sunlight. So think about that example as you do this. And I want you to identify the control group, the independent variable, and the dependent variable, and then just answer the other questions. What might his conclusion be? And it's kind of important is this fifth question. How might he have improved this experiment? Can you think of anything that would make that experiment better? Sometimes like it might be, well, you only compared two different plants. That's not a very good experiment. Would have been better off if you had 1,000 plants. So a higher sample size would make things a lot more, I guess, give you a lot more data. Like if I was to ask everybody in the class a question, like 30 students, I could get a lot of data, right? But if I only ask one student, hey, was that test, is that test hard? And they said, no, it was easy. That small data set would lead me to believe, oh, the test was totally easy. Well, maybe that one student found it easy, but maybe the other 29 thought it was difficult. So I would actually come to the incorrect conclusion because I didn't have asked enough questions. I didn't have a big enough sample size. So it's just an example of how we can improve experiments. So there's just 4 or 5 different cases here. Just go ahead and do that. Now for the last one, it says Lisa is working on a science project. Her task is to answer the question, does Ragouti, which is a commercial hair product, affect the speed of hair growth? Her family is willing to volunteer for the experiment. So take Homer and Bart and Marge and Maggie, let's say, Grandpa, if you want, make a science project with them and design me an experiment. So design an experiment with a control, your independent variable, and your dependent variable, and see what you come up with. And that is all for today. So feel free to watch this video as much as you want. Try to be able to figure out what controls are and what these two types of variables are. And we will talk a little bit more about this tomorrow. Have a wonderful day.